In this video, we're going to use the integral mean value theorem to estimate the value of the given integral. So first, let's quickly go over what the integral mean value theorem is. It states that if f, the function, is continuous on the interval from a to b, then there is, let me write that better, there is a number c, okay, which is inside the interval from a to b. And notice that c is not going to be equal to a or b, right? That's why it's an open interval, such that f of c is equal to the average function, okay? The average of this function, okay, which is going to be this. And why it's an average? Because you're dividing basically by the interval, right? By the length of the interval, this whole integral. And the integral represents the area, okay, under a curve. Right, so you're taking this area, basically the sum of infinitely many rectangles if you're dealing with summation, and then dividing by the interval length to give you the average of the function. Okay, so there must be the c for, as a number in the interval from a to b, not equal to a or b, such that the function of that c value is going to be the average of the function. Okay, so now notice that by the extreme value theorem, we must have the minimum value of the function. We can label it as m, okay, which is going to be less than or equal to the average function, so we're going to label it as f of c, is less than or equal to the maximum value, right? So the average must lie between the minimum and maximum values, right? That should be clear. So now let's substitute this in. So we're going to have 1 over b minus a, the integral from a to b, fx dx is less than or equal to the maximum value. Okay, so what does that mean? That means that you can actually multiply all three sides by b minus a, and you will get this. M times b minus, small m times b minus a is less than or equal to the integral from a to b of, my b's are just a disaster. Okay, like that. Fx dx is less than or equal to capital M, the maximum value, multiplied by the b minus a. Okay, so now as you know, this will help us determine possible values of the integral. Okay, notice that in the middle we have the integral, right, that we will need to integrate. So let's say if we cannot integrate the given integral, we can find possible values or the range of the values using the integral mean value theorem. Okay, so as an example, let's try to integrate and find the value from pi over 2 to pi over 3, the integral of 3 cosine x squared dx. So notice first of all that b minus a in this case is going to be, so I'm just going to separate this part. So b minus a is going to be certainly pi over 3 minus pi over 2. And that is equal to, wait a second, I think I gave you the wrong limits. It should be from pi over 3 to pi over 2, right? Because pi over 3 is less than pi over 2. Sorry about that. So pi over 3 to pi over 2. Okay? So now b minus a is going to be pi over 2 minus pi over 3, which is gives you 3 pi minus 2 pi over 6. That's pi over 6, right? Okay, so that's b minus a. So now using the inequality we have here, let's find the m value, the minimum value. The m value, the small value there for the function, is going to be using the pi over 3, right? Is going to be the f of a. Okay, so the f of pi over 3. So what is that going to be? That's going to be 3 cosine pi over... Well, actually, here's the trick. Here's the trick. Notice that actually in this case, cosine of pi over 3 squared is going to be greater than cosine of pi over 2 squared, right? So you can check that in your calculator. So this is a little bit tricky, right? The minimal value will be actually achieved with b rather than a, right? So you just have to check that in your calculator, right? So f of b is going to be f of pi over 2. That's going to give you the minimal value of the function, believe it or not, even though pi over 2 is the upper limit, right? So you can think of this as a curve in which the function is actually decreasing, okay, as you increase the angle, theta, right? So f of pi over 2 is going to be 3 cosine of pi over 2 squared. All right, and the maximum value of the function will be f of a, and that's going to give you f of pi over 3, and that's going to give you 3 cosine of pi over 3 squared. So now using the inequality, getting back to it, we will have 3 cosine of pi over 2 squared multiplied by b minus a, which is pi over 6, is less than or equal to the integral that is given from pi over 3 to pi over 2, 3 cosine x squared dx is less than or equal to 3 cosine pi over 3 squared multiplied by b minus a, which is pi over 6, right? So now to find the range of the possible values for the integral, all you have to do is just plug it into your calculator, the lower and upper limits here that we've created, and see what you get. So making sure that I'm in the degree mode, I'm going to get pi over 2, square that, get the cosine of it multiplied by 3, and then multiplied by pi over 6. So I get negative, I'm going to round it to the nearest tenth. So negative 1.23, right? That's going to be rounded to the nearest tenth, which is the lower value of the integral in question. Okay. 3 cosine x squared dx is less than or equal to, now let's find the upper limit for this integral. So it's going to be pi over 3 squared times, so pi over 3 squared cosine times 3 times pi over 6. So that's going to give me the upper limit, which is going to be rounded to the nearest tenth as 0.72. Okay, so once again, this integral is approximated from the least value, negative 1.23. It's between negative 1.23 and between 0.72, the endpoints included. Okay, so this is how you use the integral mean value theorem to evaluate or give the estimate of the value of the given integral. So I hope this tutorial was useful to you. Please subscribe to my channel, and I'll see you in my next video.